Hey everyone. So let's talk about that big jump, the one that takes you from being someone who just writes code to someone who actually architects software. We're going to dive into advanced object design and really figure out how to turn those cool ideas you have into truly great, solid architecture.
I mean, this is the question, right? It's the one every single one of us in software engineering asks. You've got this amazing idea in your head, but how do you get it out and into the world as a piece of software that not only works, but is also smart, efficient, and easy to maintain down the road? Well, that massive gap is bridged by one thing: design.
And hey, if this whole process feels kind of huge and overwhelming sometimes, you're not wrong. It's not just you. As you can see here, it's an academically recognized complex task. But you know what? Complex doesn't mean impossible. It just means it's a puzzle. And today, we're going to give you the pieces you need to start solving it. Okay, let's get right into it. Every single incredible structure you can think of, whether it's a massive skyscraper or a really complex app, it always starts with a solid foundation, a framework. And for us, in software, that all begins with building the skeleton. This is such a great way to think about it. That very first phase, the analysis, where you're just figuring out the main concepts in your system. The user, the product, the order. Those are your objects, and they literally form the skeleton of your entire application. They give it its shape, its structure, the absolute core of what you're building. It's the first step, and it's essential, but it's still just the bones. Right, because a skeleton on its own isn't all that useful, is it? So this brings us to the next, and I'd argue the most critical part, object design. This is where we put meat on those bones. It's where we add the muscles, the nervous system, all the tiny details that actually bring that skeleton to life. And this little flowchart shows you exactly where object design fits into the whole process. See? You start with analysis, you find your objects, you build that skeleton. Then you zoom out a bit for system design, figuring out the high-level structure, how the big pieces talk to each other. Then you zoom right back in for object design. And that's our focus today. It's where you add all those rich, nitty-gritty implementation details. It's the real bridge between a cool idea and an actual plan. So what is object design, really? Well, the key word here is refinement. You're not starting over. You're taking that skeleton from your analysis and you're building right on top of it. You're finally answering all the how questions. How is this checkout process actually going to work? Well, that's an algorithm. How are we going to store user information? That's a data structure. And hey, can we rearrange these classes to make them faster? That's restructuring. This is where the blueprint gets real, fast. So what does adding details actually look like in practice? Well, it's these things. You're going to sharpen up your class definitions. You'll look for patterns so you can use inheritance smartly, instead of writing the same code over and over. You might create abstract classes as templates for other classes to follow. And here's a really good one: delegation. You use this when one class is kind of like another one, but not really a true subclass. So instead of inheriting everything, it just delegates or hands off a specific job to a helper class. It's like a manager. They don't need to learn accounting. They just delegate the numbers to an accountant. It's a super flexible and powerful tool. Now, all of this amazing design work is fantastic, but if it's all stuck inside your head, it's pretty much useless to a team, right? It has to be communicated. And that leads us to the single most important output of this whole phase, the software design document, or the SDD. And trust me, this is not just boring paperwork. This is the blueprint for the entire project. The SDD is basically the project's single source of truth. It's the official written guide to the software's architecture, and it's what everyone on the project leans on. The developers writing the code, the designers working on the UI, even the stakeholders who are paying for the project. Everyone looks at this document to know exactly what's being built and how. And inside that documentation, you're usually going to have two different levels of detail. Think of the high-level design, the HLD, as the big city map. It shows you the main neighborhoods, the major highways connecting them, the overall flow. Then you have the low-level design, the LLD. That's the street-level view. It shows every building, every one-way street, the logic for every single traffic light. You absolutely need both to get where you're going. So why bother with all this? Is it just extra work? No way. A good SSD is a superpower for your project.
It makes communication between teams 1,000 times easier. It gets rid of confusion for developers so they can just focus on building. It makes testing way more straightforward. And maybe most importantly, years from now, when someone has to maintain your code, this document will be their absolute best friend.
Okay, so you get why it's so important, but what about the how? Let's switch gears and get super practical. Let's look at the actual toolkit you're going to use to build a professional level design document. Here you go. This is basically your checklist for a great SDD. You need that big picture system overview. You absolutely need visual architecture diagrams. Then you zoom in on the design for each component, and for your data, that's where things like ER diagrams come in. You've got to define your interfaces, like APIs, and think about critical stuff like security and performance. And finally, be honest about any assumptions or dependencies you have. And to actually make all those things we just talked about, you're going to need a toolbox. For a software engineer, that means things like UML diagrams, class diagrams, sequence diagrams, to show how your objects interact. You'll use ER diagrams for databases and wireframes for UI. And the best part? There are so many incredible, often free, tools out there like Lucidchart, Draw.io, and Figma that make creating these professional-looking diagrams really, really easy.
All right, time for a pro tip. This is what separates a good design from a great one. See, building a system that just works is one thing, but building a system that works efficiently when it's under stress, that's a whole other level. And that's where design optimization comes in. So while you're designing, you have to be thinking about performance. Sometimes that might mean adding a shortcut between two objects to make looking up data faster. It means looking at a complex calculation and thinking, can I rearrange these steps to be more efficient? And a classic one is saving derived attributes. Basically, any value you calculate from other data. You save the result so you don't have to waste time recomputing it over and over and over again. It's kind of like caching, but you're thinking about it at the architectural level. It's a game changer.
So we've covered the what, the why, and the how. To wrap this all up, let's talk about the simple do's and don'ts. These are the habits that separate a useful, living document that your whole team relies on from a useless file that just gets lost in some forgotten folder. Here are the do's. Simple. Keep it clear and concise. Use diagrams. A good picture is worth 1,000 lines of technical text. And here's the golden rule, the most important one. Your SDD has to be a living document. If the code changes, the design changes, and the document must be updated right away. Always. And make sure you can trace every design decision back to a specific requirement. And on the other side, these are the traps you have to avoid. The number one thing that kills a design document is outdated information. Seriously, misleading documentation is worse than no documentation at all. Also, avoid using super dense jargon. Don't ignore version control, and don't create a document that's impossible to read. Every one of these mistakes just chips away at the trust and value of your blueprint. So, I'll leave you with this to think about. After everything we've gone over today, from building that initial skeleton to crafting that detailed blueprint, think about your next project. Are you just going to write a bunch of code that happens to work right now? Or are you going to step up and use these principles to create a lasting, scalable, and maintainable architecture? The choice is totally yours. Thanks for tuning in.